Today's lesson is about vertical and horizontal shifts of sine and cosine. Next time when we actually take notes, um, as far as shifting goes, we will be doing a lot of more stretching, not necessarily shifting, but stretching and compressing, in addition to shifting as well. So kind of breaking this down in a couple of days, just making sure we master this before we move on. First thing I have down is the parent functions. I want to be sure that we just understand fully about the sine and cosine before we start shifting them. I have some critical values there, and I have 5 of them. And I just, in class, I talked about today as far as that each point is 90 degrees away from the previous one. So 0, 90, 180, 270, 360. Same over for cosine. Remember, the only difference between sine and cosine is sine starts at 0, cosine starts up here at 1. If it was in radians, it'd be from 0 to pi over 2, and then another pi over 2, which is pi, another pi over 2, which is 3 pi over 2, another pi over 2, which is 2 pi. So that's how we're getting those numbers, and that'll come in handy here in a moment. Just like with any type of shifting vertically, the 5 is on the outside. Excuse me, sorry. So we would shift this whole entire graph, x squared up 5. Same thing for this. So my transformation is a vertical shift up 5. And if I want to graph that, that means that my lowest value for sine, instead of being down here at -1, if I add 5 to that, it's going to be at 4. My highest value, instead of being at 1, is going to be at 6. And my middle value, instead of being at 0, is going to be at 5. So that's kind of where that 5 comes into play. And then every 90 degrees, right, we have a new point. So I start off here at 5, then 90, then 180, 270, 360. And boom. Well, get your arrow, and boom. So that's it. That's all we're doing today. So number 2, if it's negative, that just means we're going down. So a vertical shift down 3 units. And so it's the same thing. I'll go over here. Instead of being up here at 1 and all that stuff, we're going to be down here. So -4, -2, and then my middle number is -3. And the same thing at 90, I'm going to be, or sorry, at 0, I'm going to be here. 90, 180, 270. Oh, sorry, I messed that up. 90, or sorry, 0 is -3, 90 is here, there, boom, and boom. So there's my graph again. Got it there, got it there. Remember, our amplitude is still 1. Amplitude yesterday was with this number in front, right? And so for all these, our amplitude is 1. I think 1 or 2, your homework, your amplitude is a little different. Just try and mix it up a little bit. Number 3, anytime we have that number on the inside of the parentheses, just like with quadratics or cubics or anything like that, it means a horizontal shift. And so if I had x plus 2 on the inside, that was actually left. So this one's going to be a horizontal shift left 2. So as far as that goes, graphing it goes, we're not going to start at 0 anymore. That means my first point is going to be -50 degrees. My amplitude is still 1, so my highest and my lowest point 1 and -1 respectively. Then I'm going up by 90 degrees. So next one's 40 degrees. Next one is 130. Let's see, 210. Sorry, 220, my bad. And then lastly, 310. So I still start here. My next one's here. And hold on one second. Sorry about that. Anyway, like I was saying, our next point is going to be at 130, next point 220, and then lastly. So it still has the same shape. The sine graph isn't changing at all as far as what the shape goes because our amplitude is still 1. Last one, sine of theta minus 3 pi over 4. That's a horizontal shift. And I'm sure you guessed it by now. To the right, 3 pi over 4. So my graph, I'm going to get a different color. Sorry, I'm running out of space here. But my first value, that's a terrible graph. My first value is at 3 pi over 4. And so since I'm going up by pi over 2, I'm going to add pi over 2 to that. And that's like adding 2 pi over 4. So I got 7 pi over 4. Move this over a little bit. 9 pi over 4, and then lastly 11 pi over 4. Amplitude is still 1. This is a terrible graph. I'm so sorry. Start here, there, boom, boom, and boom. So it still looks the same. It's just figuring out, what my values are going to be, all that stuff. The thing I have not talked about yet that's kind of been staring us in the face right here is this thing, sinusoidal axis. The sinusoidal axis is something that I have drawn in right up here. You can almost see it right here. The sinusoidal axis is the thing that cuts the graph in half. So for like 1 and 2, my sinusoidal axis is actually y equals 5. And then for number 2, where did it go? Yeah, my sinusoidal axis is y equals -3. For my 3 and 4, sinusoidal axis is still the axis, or sorry, still the x-axis. So sometimes the sinusoidal axis will be the x-axis, sometimes it will not be. The last thing I want to talk about is uh, talking about y equals sine of theta versus y equals negative sine of theta. And then we're supposed to be comparing here. Sorry, I must have erased that. And same thing for cosine of theta and negative cosine of theta. Essentially what happens here, I'm going to get my calculator app here. Come on, Cap. Oh, that's right. There we go. If I were to go in here and I was going to graph sine and negative sine of x, got to change my window back there. You got to be in radians for this to look right. But I got this little blue line that's going. That's my sine of x. That's blue right there. And then my other one's going to flip here and be red. Boom, boom, boom. So it flips across that sinusoidal axis. It's negative. In this case, the sinusoidal axis is the x-axis. If I were to go back in and put a little 5 in there and raise my graph up, it's not going to reflect it, I think, like we should. So there's my blue line. And I think a lot of us should think that, oh, my red line should be down here, right? Well, that's not the case. It just reflects up here. So that's the difference. Before, when we're doing like x cubed and all that stuff, is up here, or x squared. If I had x squared plus 5 and negative x squared plus 5 would be down here, all that stuff. Well, in this case, it's just up here the whole time. All right, that's that. I know we went quickly. Come on in if you need for tutoring. I'm proud of y'all for doing such a good job. Bye.